Hello everyone. Welcome to Programming in C for Beginners. I'm Amit Kumar and this is the 32nd tutorial, Linkage Part 1. Friends, in our previous tutorials, we have discussed about plenty of things related to variable declaration, and basically our focus was on the scope and visibility of identifiers declared with different storage classes and declared at different places. So today we are going to discuss on linkage, which is somewhat related to that only. So let's proceed. Identifier names can refer to different identifiers in different scopes. An identifier declared in different scopes or in the same scope more than once can be made to refer to the same identifier or function by a process called linkage. Now, if there are more than one identifiers at the same place, and then you are accessing a specific identifier over there, definitely the compiler might call any of those two identifiers. So let's see an example. Let's suppose we are having two variables with same name of different data type and declared at two different places. But at the place where I'm accessing the variable, both the variables are having visibility of that place. So which variable will be accessed at that moment of time is actually decided by the linkage. Now linkage determines the portion of the program in which an identifier can be referenced, right? So there are three kinds of linkage: internal, external, and no linkage at all. And in this tutorial, our focus will be on internal linkage. Now if the declaration of a file scope identifier for an object or a function contain the storage class specifier static, the identifier has internal linkage. Otherwise, the identifier has external linkage. It means to say, if the declaration of a file scope identifier, now they are talking about a file scope identifier for an object or a function, contains the storage class specifier static, right? So if that is containing this storage class specifier, then it is having an internal linkage. Otherwise, it won't have an internal linkage, it will have an external linkage. Now you might be wondering, what's the difference between internal linkage and external linkage, or what will happen if my identifier is linking internally or linking externally? So the same thing I will explain in the practical part of this tutorial. So be with the tutorial and you will come to know about it. Don't worry. Now within one translation unit, each instance of an identifier with internal linkage denotes the same identifier or function. Internally linked identifiers are unique to a translation unit. This is very important. Okay. So if a file scope identifier, an identifier declared outside all the blocks, right? So if a file scope identifier have the storage class static, then that would be an internal linkage. If it is not having static, then it won't be having internal linkage. In fact, it would be externally linked. Now, one translation unit means a single program, and each instance of an identifier with internal linkage denotes the same identifier. What I mean to say that this identifier will be unique throughout the program. And now it's time to see this thing practically. Okay friends, so here we are on our Visual Studio Code, and I have definitely created this tutorial 32.c. Now you can see in this tutorial 32.c, I'm including stdio.h, I'm having main method, and I'm calling fun function, and I'm also returning 0 from the main. Now you might be wondering that it will give an error, and definitely it will give an error when I will run this certain program. Just a second. Okay, so here you can see it's giving an error, and the error is expected identifier or brackets, right, before return. So want any identifier or anything like that, and because fun is not being recognized, this certain error is there. Now how to resolve this error? Now I will tell you that within a while, but before that let me show you where I have defined this fun function. Now here I have created my helper.c, and inside this my helper.c I'm having this hash include stdio.h. I'm having these two variables and I'm having fun function. Now this was the function which I tried to call there. Now let me tell you what is a translation unit. Whenever we are talking about a translation unit, then a translation unit represents the program, all the functions or the identifiers in it, as well as the file, the header file which is being included. So stdio.h and this main function composed one translation unit, and here this fun function, these identifiers and this stdio.h is forming another translation unit. So there are two different translation units, right? Now definitely this fun function cannot be used here because it belongs to the internal scope or internal linkage. Similarly, this a variable and x variable cannot be used here, right? But actually this x variable can be used. We cannot use this a. Now why so? This x variable is having an external linkage, and that is something we will discuss in the next tutorial. But let's talk about this a. We cannot use this a because it is having internal linkage. It can be used anywhere inside this whole program, inside this whole translation unit, but it cannot be used outside it. Okay, so let me show you that. Let me try to access this a. So I'm copying this line and I'm pasting it here. And now let's see whether it will print the value of a or not. We need not to even run this. You can clearly see the error, right? See, a is undefined. But if we will make these two programs as a single translation unit, definitely we can access it, right? So let me tell you how we will do that. To make any certain program as a part of another program translation unit, all that you need to do is to include that program over here. So here I am including #include myhelper.c. Now the thing is, if you will include as I have included right now, it will be an error. Now why it would be an error? So let me save this file and let me run, and then let me tell you why it would be an error. So I have run the program and clearly you can see it is showing error on myhelper.c, and it is saying that no such file or directory found. The reason is that whenever we include any header file or any file with this angular brackets, the compiler tries to include that file, tries to find out that file in the default folder of the C library or the C compiler. But if we want our compiler to fetch the file in our directory, in our folder, then we should not use these angular brackets. We should use these double quotes. So if I will use these double quotes, so now because myhelper.c is also compiled with this file, so both of them forms a translation unit over here. And when I will run this program, definitely I will get the output what I was expecting. Let me clear the screen and then let me show you the output. Okay, so now let me run it again, and you can see the output main is 100, and if you remember, I have assigned a as 100. Now even I can access this x. Why? Because both are in the same translation unit, right? So I'm just copying this one and pasting it and printing the value of x. So let me run this one more time after clearing the screen, but of course, and here you go. Now you will get the output in main of both the variables. Why? Because they are part of the same translation unit. And if we talk about same translation unit, all the internal as well as the external linkage can be accessed over there. Now definitely external linkage is something that we will discuss in the next tutorial, but I hope you understood. If any file scope identifier, I mean to say only file scope, no other. If any file scope identifier is having static keyword assigned to it, it belongs to internal linkage, and that's something we will discuss in the next tutorial. So that marks the end of this tutorial. Hope to meet you in the next video tutorial. Till then, thank you and happy programming.